Okay, guys, we're going to start. This is section 2.1. Okay, I'll write that a little bit darker. Okay, and this is relations and functions. Okay, and I'm going to kind of break my I first could have kind of break my table up like this, and I'm going to go down and do probably, I don't know, 6 or so, maybe 8 different spots. We have a lot of vocab to cover in this section, so I want to make sure to give myself enough space. So one of the first things that we need to tackle here with relations is really talking about what a relationship is. And it is a set of points. They don't have to be connected. They can be given to you as ordered points. For example, -2, 2, -2, -2, 0, 1, and 3, 1, for example. Okay, so this would be ordered pairs. Okay, they don't have to be a dot to dot in any way, shape, or form. They can also be given as an XY table. So X, Y, like this. So -2, 2, -2, -2, 0, 1, and 3, 1. So this could be as a table. We can also graph them. Okay, on a graph, -2, +2, -2, -2, 0, 1, and 1, 2, 3, 1. Okay, so this is a graph. And one of my ways I really like to try this is I always like, this is called a map. You only have to mention it once. If you use it twice, that's okay. Same thing here if we have repeats. So 2, -2, and 1. And what you do is you draw lines to, so -2 goes to 2, okay? And -2 goes to a -2, okay? And 0 goes to 1, and 3 goes to 1. Okay, so those are all relations. It's just a group of numbers that doesn't have to form a line, doesn't have to do any of that stuff. It just is a set of points, okay? So one of the first things that we want to talk about with these, let's look at some of our vocabulary. So what's our domain values? Well, our domain values are my input values. Those are my X values, okay? My range, those are my outputs, okay? Those are my Y values, okay? Those are my Y values. So that's kind of important that we talk about those. Now, I'm going to give you the definition of a function, and then we're going to practice it. A function is, okay, a relation where each input has only one output. Okay? So in this case, we're going to use this box to do function or not. Okay? So the first thing, oops, sorry, I was starting to move it. So the big question I'm going to draw in from our example is this a function? So do you see how there's two arrows coming? This is an example of no, you can't have. So right there, when we have -2, 2, and -2, -2, do you see how we repeat the inputs? That does not work, okay? Also, I'm going to highlight this, and I'm going to use a different marker to come up here. Do you see how these are right over top of one another? So on a graph, it's called the vertical line test. Okay, so if you draw a straight line, a function should hit only 1 point. Okay, so friends, if we were to put your pen right here, how many points is it hitting? Ooh, it's hitting 2 points. So that doesn't work, does it? So that fails the vertical line test. So this example of this relation does not show a function. Does that mean it's bad? Well, no, but it doesn't show a function. Okay? So that just took care. So let me do this. Let's do a practice, okay? So practice. And it's going to be function or not. Are you ready? Okay, so this is going to be example letter A. So I'm going to give you a map. Are you ready? So -2, -1, 3, and 6, and 1, 0, and 4. And I'm going to draw okay. And I'm going to give you B now. I want you to see if you can tell the difference. Be careful. Go back to what the definition. I don't know why I mentioned 2 twice here. I didn't really have to, did I? Okay. So 1 is a function and 1 is not. Which one is going to be your function? Now we're looking for double arrows coming from the same input. So this is your input, this is your output. Input, output. Okay, so which one do you think is not a function? You're right. That is not a function. Right there at the 2. That doesn't work, does it? Okay. If you were to graph it, 2, 2 and 2, 3 would be right over top of one another. 2, 2 and 2, 3. And look at, if we were to do the vertical line test, oh my, it hits both those points. So that doesn't work at all, does it? All right. Questions on that piece? Okay. Now, we go through graphing. We're not going to go through graphing as far as this section because we're certainly not plugging and chugging things away. So we're going to practice linear. So if something is linear or not. So what does linear mean? Well, linear means straight line. Okay. So keep in mind that this is not dealing with function or not. This is dealing with linear. You can be a function, but yet not be linear. Okay. So that doesn't work on that piece. So linear means we want to be x. X is to the first power. So you're probably not going to see a power on it. It's not going to be in the bottom. It's not going to be raised to a power. It's not going to be It's got to be just x. And it's just got to be to the first power. Okay, it can't be up in the exponent. So here's examples of not. It can't be an absolute value of x. It can't be up in the exponent. It can't be a squared. It can't be down in the basement. It can't be any of those things. Okay, that doesn't work. Those are all things that are not linear. Okay. The next piece is so telling whether or not it's linear. So linear or not. All right, are you ready? So notice that I'm going to put things like this. This is functional notation. So f of x means that x is a function. So this is y. This is really a fancy way of saying y. So f of x is function notation. Okay. So you're going to write down here yes or no. Let me try this one. F of x is x squared plus x minus 2. How about this one? F of x equals 3 minus 3x. F of x is the absolute value of x plus 2. All right, what do you think? All right, the first one, x, is it to the first power? Yep. So this is a yes. This is linear. That means a straight line. Uh-oh. I'm a squared. That's a definite no. How about this one? X to the first power? Yep. That looks good. Uh-oh. I have an absolute value. That's a no. Now, to tie along with this, no matter if these are linear or not, you can still find out and plug and chug when you're given an x value, what is the y value? So I want you to find f of a negative 2 of each of these. So this means, okay, plug in negative 2 for x to find the y value. So f of a negative 2 is you take your x value, okay, and you replace it. Negative 2 plus 5. And that equals 3. So my answer is 3. Well, what you just found was the point negative 2, positive 3. Okay? All you did was plug and chug. No big thing. All right, f of negative 2. Let's see our next one. X squared. So instead of x squared, I'm going to put negative 2 squared plus negative 2 minus 2. And I'm going to chug that through right on my calculator if I want. Negative 2 squared is 4. Plus negative 2 minus 2. Oh, that's 0. So negative 2, 0 is my point. That's an actual point on the line. F of negative 2 is 3 minus 3 times a negative 2. Well, that's negative, that's 3 plus 6, which is 9. So my answer is negative 2, 9. And my last one, the absolute value of negative 2 plus 2, well, that's the absolute value of 0, which is 0. Negative 2, 0. Okay, so it doesn't matter if it's a function or not. These are all functions because they're all actual function notation. But it doesn't matter if they're linear or not. You can still plug and chug values. Okay, so the last piece that I want to deal with is looking at domain and range and being able to say independent and dependent variables, because all of that is pretty important. It was stuff that we actually talked about in Algebra 1, but it is a really important concept that we want to talk about, because domain and range never goes away at all. It doesn't go away. It is something that comes back over and over and over again. So we want to definitely keep ourselves up on how to do domain and range. We don't want to forget So I want to try to find maybe a paper that's not written on here. Give me a hot second. Okay, how about this one? All right, so I want to show you this paper. So let's take a look at this problem. The world population. The table shows the estimated world population in billions for the given year. Use a coordinate plane to graph the data. So it's really easy. Don't forget that these things mean a skip in the numbers. So let's go through and what would be the domain and what would be the range. Okay, well that's easy. Domain is what is on the bottom. So the first thing I would say is the domain is in years, and it looks like I want to be from 1960 through 2000. Okay, or I could write it like this: 1960 is greater than or equal, or is less than or equal to X is less than or equal to 2000. That's probably a better way of writing that value because that's really what domain range is written. So the independent variable, if you remember that from freshman year, would be in years, okay? The range would be the population, which it looks like it is from 3 to 6.1. So again, here I am writing an in-between statement of the range that ranges from 3 to 6.1. So we're going to work a lot on domain and range with lots of different variables with that. So don't be alarmed with that. I'm not going to necessarily go through and practice graphing by plugging and chugging values because we are going to work on slope and y-intercept instead. So if you want to just add that to the bottom of your notes here, that would be fine. And otherwise, we are all set. Thanks.